خب ادامه رو بریم ببینیم.
While others talk about the future, we are working on it. Since 1824, Bilfinger Knoll has been mastering the ever-changing challenges of our time with state-of-the-art technologies. We are a world-renowned company that focuses on building high-tech specialized machines and systems. One of the latest innovations, intelligent structural health monitoring for permanent safety monitoring of bridges. Germany has around 40,000 highway bridges. About 1 out of 8 is approaching the end of its originally planned service life. It often takes years to build a new bridge. Until then, traffic authorities have to strengthen monitoring and maintenance activities.
به خاطر پایین بودن سرعت اینترنت مجبوریم یه چند دقیقه توقف داشته باشیم که بتونیم یه حجمی رو پر کنیم و بعد شروع کنیم به دیدن ادامه فیلم. ببینید الان شما ممکنه ببینید این کارهایی که دارن انجام میدن برای یه پله و بگید چه ربطی به کانکروشر داره. متد همون متد هست، یعنی تو همین متدی که حالا تو فیلم قبلی دیدیم برای تشخیص ترک وجود داشت با دادن امواج، مثلا امواجی که کنار ترک بودن با امواجی که روی ترک رد می‌شدن تغییر می‌کرد دیگه. خب از این طریق متوجه می‌شدن که ترک روی ناحیه وجود داره. بنابراین شما همین متد رو ایزن میتونید پیاده کنید برای مبحثی به نام کانکروشر، یعنی فرقی نداره.
The Tal-Albach Bridge near Eichensee. Following 50 years of service and a daily traffic volume of around 40,000 vehicles, it must still meet strict safety requirements.
Hessen Mobil als Betreiber.
Hessen Mobil, the operator of the Tal-Albach Bridge, approached us with the task to non-destructively monitor a complex building structure. We accepted the challenge and installed a monitoring system. An investment that pays off in the short term. After successful commissioning, the Bilfinger Knoll Structural Health Monitoring System will now be monitoring the bridge structure for several years to come, reliably and around the clock. The timely detection of damage enables operators to plan maintenance measures ahead. In the past, our company had a lot to do with bridge construction. We were founded in 1824. From 1879 to 1979, roughly 100 years, Knoll built a lot of bridges, totaling more than 1,000.
Wir beschäftigen uns wieder ganz intensiv mit Brücken.
We are once again working largely on bridges. By using non-destructive testing technologies, we learn about the condition of bridge structures.
Brückenbauwerke zu erfahren.
A proud history of bridge building, precise materials research, and broad technological expertise. Bilfinger-Nolte has acquired unique know-how and an extensive knowledge base, a stable foundation for applying the state-of-the-art bridge monitoring system.
Die herkömmliche Brückenprüfung.
Conventional bridge inspections are visual inspections. The inspector has to check each weld seam individually. In addition, the conventional visual inspection only records the current status of.
شما یه وقت فکر نکنید که مثلا با گذاشتن فقط سنسور روی قسمت خاصی میتونید صورت مسئله رو حل کنید و چالش رو پیدا کنید و یه جورای پرابلم سالوینگ انجام بدید. نه، واقعاً چالش های عجیبی روبروی شما خواهد بود. ببین در برای یه دونه پل چقدر اینا دردسر میکشن که بتونن مشکل حل کنن.
Customer who can immediately locate the area in which the damage has occurred and arrange a follow-up inspection. Plus, our system has a self-checking mechanism as well.
Selbstprüfungsmechanismus.
Huge amounts of data are analyzed, interpreted, and visualized right when they are created, enabling traffic authorities to make the right decisions.
Das Geniale ist noch,
The great thing is that we can connect to the system, such as a bridge or a machine, without having to interrupt the process. We can listen passively, so to speak. It is clear that there will be further applications for other type of bridges, railway bridges, highway bridges, and so on. It will also cover tunnels, other building structures, and of course we can also listen to machines and other type of possible things. Road users and operators benefit in every aspect, whether from a safe extension of the service life of the bridge, the strategic planning of the maintenance work, and thus reducing traffic restrictions, or the system's alarm feature. All this is part of a monitoring system that does not require any complicated structural adaptations. A real improvement for bridge operators, thanks to Bilfinger-Nolte's structural health monitoring.
I'm Mahadevan. I'm the John R. Murray Senior Professor of Engineering here at Vanderbilt. Obviously, if you're concerned about reliability and risk analysis, it's not just a one-time thing at the beginning of the life of the system, but it's something that you...
Let's face it, the way we keep track of our health these days is kind of like driving a car whose dashboard only works 1 hour a year. That is literally the model of the annual checkup. Even Star Trek saw a better way over 50 years ago. Pervasive, comprehensive monitoring of what's really going on with you right now, we're on the cusp of that. The Omron Heart Guide. This is the FDA's first ever approved blood pressure machine that fits around your wrist. It's in its final FDA approval phase right now, going to market end of 2018. No prescription, by the way. Now, new blood pressure guidelines issued in early 2018 now mean that 46% of Americans have high blood pressure, according to the American Heart Association. That's up from 32% under the old, decades-old standard. The maladies high blood pressure leads to are almost too numerous to count, but they don't call it the silent killer just to be dramatic. That should tell you something.
این تایتل و سابجکت چقدر زیاده. فقط حوزه مهندسی مکانیک و برق نیست. در حوزه پزشکی هم ما ازشون خیلی وقت استفاده می‌کنیم. خیلی وقتا به چشممون می‌خوره و توجه نمی‌کنیم که بله این موضوع میتونه در کاندیشن مانیتورینگ کاربرد داشته باشه یا این همون بحث کاندیشن مانیتورینگ و هرتز.
The rest of the time, only constant monitoring can suss these two out. Now let's turn to a little bit of sugar. The Dexcom G6 is the latest of continuous glucose monitors, knowing what your blood sugar levels are all the time. You wear it for 10 days at a time and simply swipe your smartphone or a small dedicated reader over the thing to check or record your glucose momentarily, to build a history, or to alert family, friends, or clinicians about a crisis level you might be in. The Medtronic Guardian Connect and the Abbott Freestyle Libre round out this hot category, and all are aimed at the idea that non-diabetics will one day wear something like this to avoid becoming type 2 diabetics. Now, check out the AliveCore Cardia Band, a band for an Apple Watch, but it's actually a wrist-worn electrocardiogram machine. It's specifically designed to detect atrial fibrillation. That's when your heart kind of flutters instead of beating smoothly. And it's a key contributor to the future risk of stroke. This band is said to be about 87% accurate at detecting AFib. And like other products we've looked at, it's FDA cleared. AliveCore and Omron, who we just saw, work together. Their products can already create a single channel of information about your heart health for you or the clinician who would like to see it when something is outside the realm of normal. The last healthy heart tech I'm going to show you today
به
is
یوزر نشون بدن که میزان قند خونش رو چقدر، فشار خونش رو چقدر، نرمال هستن، نرمال نیستن، نیاز به ورزش بیشتر و چیزایی از این دست.
evidence that your voice may be an accurate indicator of whether you have coronary artery disease. 81 tonal features of voice were measured after patients spoke to a recording app using technology from a vocal biomarker company called Beyond Verbal. Upon further confirmation, this study could open the door to you monitoring your circulatory system by just talking. Where does all this go next? First, these devices need to give us answers, not just information, and answers that motivate rather than overwhelm or discourage us. Secondly, it'd be great to have a single dashboard of our health from many sensors, hopefully without us having to wear many devices. Third, make these technologies over-the-counter so we can wear them long before we supposedly need them. This does, however, set up some tension between devices that keep us well and pharmaceuticals that fix us when we're not. And fourth, recognize that everything is a health signal, from your smart home devices to your social graph.
این تست‌های آلتراسونیکه برای مباحثی مثل در واقع صوت سنجی ازش استفاده میکنن. ببینید
Bearings are a critical component of production machines. Maintain them properly and be rewarded with a long and productive life cycle. Ignore simple concepts.
خب قبل از اینکه این چیز بشه، این عنوان رو من بهتون تو یوتیوب بهتون پیشنهاد میکنم که خودتون ببینید. از مؤسسه موبیوس هست، یه مؤسسه بسیار معروف در زمینه کاندیشن مانیتورینگ. چون وقت نداریم اینجا به دیدنش رو به خودتون محول میکنم و اینجا هم دیگه چیزی نیست. آکوستیکه. ببینم اینجا خب این بحث جالبیه. این ترمال و صوت با هم
Landsweeper automatically discovers and identifies any asset in your environment. Depending
concepts like appropriate lubrication and pay consequences that undermine your competitive advantage. Poorly lubricated bearings are a primary contributor of premature machinery failure. A common mistake is to grease bearings based on time intervals instead of condition. This wastes time and lubricant and contributes to over-lubrication. Major bearing manufacturers claim that incorrect lubrication practices decrease the longevity of bearings by as much as 40%. Grease serves a simple purpose: to reduce friction and dissipate heat. Too much lubricant builds pressure inside the bearings. Too little creates excessive friction and heat. The result? Bearing fatigue, overheating, failure, and excessive energy consumption. Companies looking to optimize lubrication practices have adopted a conditional approach. By monitoring the friction levels of bearings with ultrasound, they can determine when the lubricant has deteriorated and needs replacement. Trending against an established decibel value, increased friction levels are quickly spotted and alarms triggered. It becomes a standard practice to sort good bearings from those that require the attention of the lubrication technician. Data collection is simple and not time-consuming at all. Diagnosis is straightforward, allowing intervention well in advance of failure. The SDT270 ultrasound detector from SDT serves a dual purpose. In addition to alarming when friction levels need attention, lube techs listen to the bearing as new grease is applied. Using the SDT270's digital decibel metering as a guide, only enough grease is applied to return the bearing's friction level to normal. One stroke of grease more, and the damage of over-greasing enters the equation. Another common mistake everyone makes. There are three rules to follow for optimizing bearing lubrication. First, don't grease bearings based on time and service. Grease them because friction levels have started to increase, a sure sign that the lubricant is failing. Don't use listen-only ultrasound devices. Measuring friction levels requires the accuracy and repeatability of the digital SDT270 ultrasonic data collector. Whether predicting greasing intervals or actually applying new lubricant depend on the precision of SDT's digital decibel display to avoid over and under lubrication. Are you new to the concept of ultrasound-assisted lubrication? Fear not. Getting started is easy. Visit our website or call today to speak with an ultrasound service agent. We can answer all your questions, recommend the best product for your needs and budget, and schedule a live demonstration at your plant. There are lots of things you can do with an ultrasound program. Acoustic bearing lubrication monitoring in real time is just the beginning. Our promise to you is that no matter what your ultrasound goals may be, SDT will be right there beside you each and every step of your journey. So what are you waiting for? Let's hear more together today.
واقعا این که از فیلم‌ها خیلی جالب بود که دیدیم. بریم بعدی رو ببینیم.
how you can determine if your engine has hidden damage. And to do so, I've taken oil samples from my engine after a 3,000-mile road trip. The purpose of this video is to help show what you can learn about your engine and vehicle by having an oil analysis performed. There's actually a surprising amount of information these have, and even brought up some red flags for my own car. Now, it's worth mentioning, 3,000 miles is not a lot for modern engine oils. This video isn't about when you should be changing your engine oil. I'd recommend consulting your owner's manual for that information. Instead, we're talking about what can we learn with an oil analysis. So for this test, I took 12 total samples at 3 different intervals for my Crosstrek. So we start off with fresh oil right out of the bottle, took a sample of that, then put that oil, after changing the oil in my Crosstrek, put the new oil in the car, let it idle for 15 minutes, and then I took another sample. So this makes sure anything that was left behind in that engine, we know what our starting point is with the fresh oil in there. And then after driving 3,000 miles, I took the final sample. So we've got our before and after with these 3 samples. To get those 3,000 miles, I did a nice scenic road trip and checked out the Grand Tetons as well as Yellowstone National Park, and a bear was kind enough to check in on our mileage count about halfway through. I happily reported to the bear progress was going well. So at each of these intervals, new, 15 minutes of idling, and after 3,000 miles, I took 4 samples. And then I sent out a set of samples to Mobile One, and then because this video is sponsored by Mobile One, I sent out another set of samples to a third-party lab to independently verify the results. Now, I also took a backup sample at each interval, and that's the samples that you see in front of me here. Just in case any of these were to get lost in the mail, I could have another option that I could send out. So what can we learn from an oil analysis? Well, I spoke with Mobile One engineers who manage the oil analysis for large trucking fleets, and they told me how they go through one of these sheets to look at information regarding your engine's health, as well as how much remaining life you have within your engine oil. We'll go through this based on 4 main themes. First, what's our engine health? Second, what's our oil health? Third, how did the third-party lab results compare? And fourth, what were the red flags that came up for my car? Starting with engine health, Mobile One engineers stated the first things they look at on an analysis are the wear and contaminant blocks. Both of these blocks are measured in parts per million, or ppm, meaning the quantity of these metals present out of a sample of 1 million parts. As we look at the data throughout this video, note that the first column represents the first oil sample, fresh oil, the second column represents the second sample after 15 minutes of idling, and the third column represents the third sample after 3,000 miles of driving. Worth mentioning, molybdenum is present in the oil itself, so you're looking to see if there's a significant increase. With all the other metals, the starting point is essentially 0, and if you see a significant increase, it can be indicative of certain engine components wearing. For example, a spike in aluminum could mean piston, block, or cylinder head wear. Copper could mean worn bearings, iron could mean worn cylinders, crankshaft, or camshafts, and I've provided a fairly generalized list of what certain metals could mean for how engine components are performing. The only and very slight increase on wear metals from the Mobile One analysis was iron at 4 ppm starting at 0, not enough for it to actually matter yet, and that matches with the third-party results for both aluminum at 2 ppm and iron at 4 ppm after 3,000 miles. Aside from wear metals, the other part of engine health is looking at contaminants. Potassium and sodium can be introduced through the engine coolant. Seeing a noticeable spike here could mean that engine coolant is making its way into the engine oil, and this could be indicative of a head gasket failure. Mobile One says if this number is over about 75 parts per million, that's when you want to start being concerned. The good news is for my engine, it was well below that. Silicon, which will commonly come from sand or dirt ingress into the oil, can help indicate how well the air filter is functioning. This is a particularly important metric to focus on if you're running an aftermarket air filter, which might not filter out contaminants as well as an OE filter. Silicon is very hard and abrasive, so if you get a significant amount of it in your oil, it starts to chew up your engine internals. In speaking with a company that operates in the rally space, they said their biggest challenge was finding air filters that could properly hold out dirt from getting in the engine, which then chews up the cylinder liners, you start to get lots of blow-by and oil consumption, and ultimately ruin the engines. Silicon can also come from RTV, an engine sealant used in assembly. And finally, regarding engine wear, Mobile One reiterated the importance of changing out your oil early on the very first time when you're breaking in that engine to make sure those initial contaminants and wear metals that are present when the engine is being built are removed quickly and taken out from that initial break-in period. It's not the synthetic versus conventional debate that's important for break-in, though I use synthetic for my cars, but rather that you change the oil early the first time to remove contaminants from the initial manufacturing and break-in period. Now that we know the health of our engine, we want to check the health of our oil. So this lets us know whether we can continue using the engine oil or if it needs to be changed out. So we have a block on our analysis dedicated to
وجود یه چنین تیبل هایی خیلی به ما کمک میکنه، ولی خب باید خیلی تو دیتیلش وارد بشیم. یعنی تو بحث روانکاری حالا برای کانکوروشر ما به یه چنین تیبلی روبرو میشیم، یعنی روغنی که توی مدت مشخص استفاده شده اون روغن استخراج میشه و میاد آنالیز میشه روش. حالا اون آنالیزه با یک سری روش‌هایی که نمونهش رو حالا من در جلسات گذشته بهش اشاره کردم از طریق یه فیلمی که داخل یوتیوب بود و حالا روش‌های دیگه‌ای که باید واقعا وارد دیتیلش شد. اونجا شما متوجه میشید که مثلا بر اساس میزان اون ببینید مثلا اکسیداسیون یا میزان اون مواد در واقع شیمیایی مثل حالا از لحاظ میزان کربن، آلومینیوم یا سایر فلزات موجود در روغن یا سایر مواد در واقع شیمیایی که داخل روغن هست، شما میتونید متوجه بشید که سازه شما، سیستم شما یا به اصطلاح کانکوروشر شما آیا از عملکرد خوبی برخوردار هست یا نه. یک سری معیارها و ایندکس هایی داره تحت عنوان پرفورمنس ایندکس بهش اشاره میکنن، شاخص عملکردی. شما با استفاده از اون شاخص عملکردی میتونید سیستم رو مقایسه بکنید با یه چنین تیبل هایی که میشه در اثر اون ریپورت آنالیز روغن بهش رسید و مقایسه رو انجام داد. حالا نمونه بارز همه اینها فرکانس های طبیعی هستن. یعنی شما یک بار روغن سالم رو ریختید تو سیستم، فرکانساشو رو گرفتید، در همون بعد شروع ریختن روغن و کار کردن سیستم، دوباره بعد از یک ماه دیگه اومدید روغن رو در واقع میشه گفت ارتعاشات سیستم رو گرفتید، فرکانساشو رو دست آوردید، اون روغنه رو دوباره استخراج کردید. یه بار روغن در بار اول یه ریپورت اینجوری داشتید، یه بارم آخر سر بعد از یک ماه که از سیستم یا کانکوروشر خارج کردید. حالا میاد این دوتا رو با هم مقایسه میکنید، خواص مکانیکیش رو، لحاظ لزجت، لحاظ ویسکوزیته و چیزهای دیگه که حالا در دوستانی که در رشته شیمی هستن خیلی با آنالیز بیشتری روبرو هستن، با مباحث بیشتری روبرو هستن. مهندسان مکانیک هم میتونن این مباحث وارد بشن، ولی خیلی نیاز نیست که وارد دیتیل بشین.
The lubricant. First step is fuel dilution. Obviously, you don't want to see fuel mixing in the oil. It's a sign you're potentially running rich or have excessive blow-by, possibly a fuel leak, and this will thin out your oil. Now, I have an alert here from Mobile One. We'll get into the cautions at the end. But after 3,000 miles, Mobile One reported low fuel dilution, and the third party said no fuel showed up. Next, we get to total base number, or TBN. So as you have combustion occurring, blow-by gets past this piston and can cause contaminants to enter within your engine oil here in the crankcase. So those contaminants can cause acids to form. To counteract acid formation, you have calcium and magnesium in the oil, as you can see is present in the additives. Calcium and magnesium neutralize these acids, so your TBN is basically telling you how much acid-fighting power the oil has left in it. As it gets lower, you need to replace the oil. The third-party lab says you want your TBN to be above 1, and after 3,000 miles, again, not that many miles, the TBN value measured was above 1 by both Mobile One and measured by the third party. Now, viscosity is obviously an important metric for motor oils. It's the big numbers you see on the side of the bottle. So in this case, at 100 degrees C, our hot rating is this SAE 20 grade. And so an SAE 20 grade oil should have a viscosity between 6.9 and 9.3 millimeters squared per second. And our Mobile 1 results show that happening. So it's starting off at 8.6 and then ending up at 7.4. If the viscosity measurement is too low, it could be indicative of fuel or water getting into the oil. If the viscosity is too high, it's likely a result of oxidation, meaning the oil is no longer usable and needs to be changed. Which leads us to oxidation, which is one of the biggest factors in determining the health of an oil. So oxidation is oxygen mixing with that oil and degrading it, and it's going to happen no matter what. Your goal is to simply delay this process as long as possible. Oxidation causes the oil to thicken, form sludge and deposits, and accelerates the degradation of the oil. Antioxidants are used as additives to delay this as long as possible, but once it starts happening, you'll notice the viscosity of the oil can start to change, and this can happen quickly once it starts to get bad. Obviously, you want to change your oil before it gets too thick. In this case, after 3,000 miles, there isn't any noticeable oxidation. Nitration is a somewhat similar idea to oxidation, except in this case, it's nitrogen that's mixing with the oil, that nitrogen coming from nitrogen oxides, which are formed during combustion, then making their way past the piston from blow-by and mixing with the oil. It causes degradation to the oil, and in this case our measurement shows a small increase in nitration, but not enough to warrant changing the oil. Soot is a collection of carbon particles that form from incomplete combustion, and if this soot gets into the oil, it can shorten your oil filter life, and also act abrasive to the engine. Also, too much soot can overload your exhaust emissions equipment. Since this is a port-injected gasoline engine, soot really isn't an issue, but for modern direct injection gasoline engines, as well as diesel engines, it's definitely something you want to monitor. In our case, measured levels were very low. Finally, you want to make sure your oil doesn't have any water or coolant content. This can reduce the oil's viscosity and thus reduce its effectiveness at protecting your engine. Thankfully, both Mobile 1 and the third-party analysis did not find any coolant or water in the oil. Now, as mentioned, I wanted to make sure I could trust all the results, so I sent samples to 2 labs, and for the most part, both labs' results matched well.
خب مجبوریم این تبلیغات رو هم رد کنیم و هم تحملشون کنیم.
Especially when you consider the tolerances of some of these tests. Now, I did want to provide the third party's assessment of the oil after 3,000 miles, and what I found a bit surprising about it was just how lighthearted and happy-toned this analysis was. I mean, this is, an oil analysis we're talking about, but they seem pretty amped, pretty passionate about it, so that was excited to see. Anyways, they say, Jason, we're glad this oil is still in use because 3,000 miles was no sweat for your cross-trek. Universal averages for this type of Subaru engine show typical wear after about 6,200 miles of oil use. You haven't gone that long on this oil yet, and wear metals are much lower, just as one might expect. No internal issues stand out in this data, and there isn't any indication of poor wear. Low silicon and insolubles show the air and oil filters are both doing a good job, and no fuel or water showed up. The TBN is good at 5.7, so add another 2,000 to 3,000 miles to this oil. Very nice. How about that? Happy, excited oil analysis. Worth mentioning, third-party labs don't know what type of oil you're using, so they're unlikely to recommend a change interval longer than the manufacturer recommendation. Mobile One's testing has shown these oils can last as long as 20,000 miles, and I have a video showing the validation testing involved of a long-life oil if you're interested in checking it out. Now, that is not to say that there were not any cautions brought up. Mobile One had 2 things that they noted to be concerning. First of which was fuel dilution as a percentage of volume at 7.62%. So that is pretty significant, all things considered. Now, this was after just 15 minutes of idling. So the engine was cold, it idled for 15 minutes, warming itself up before I took that sample, but then it says the fuel dilution was 7.6%. So if there was that much extra fuel being dumped into the cylinders and then making its way into the oil, I think there would be other signs that that was occurring. So it may just be that this was a misleading data point. Either way, at the 3,000 mile mark, the fuel dilution was not anywhere near what that measurement was, and so as a result, neither the third-party lab nor Mobile One seeing a significant amount of fuel in the oil at that 3,000 mile mark, so I don't think that one needs much concern. There was one more caution from Mobile One in the oil viscosity. Mobile One measured this at 7.4 and the third party at 7.31, so similar results after 3,000 miles. Now, you could expect to see a small drop in viscosity from shearing viscosity modifiers. These are large molecules that are additives, and if you break up these large molecules, then you're decreasing your viscosity. The important thing is you don't want to see the oil fall out of its SAE viscosity grade, and in this case, it does not. Speaking with Mobile One, they believe the initial viscosity drop is normal, where the viscosity will then plateau and then slowly increase in viscosity as it reaches the oil's end of life. So while this is generally expected behavior, I did take a look at some of the potential causes for a viscosity drop just to make sure everything looked in order. It could be that the fuel injectors are leaking or running a bit rich, and fuel is getting into the oil slowly, decreasing the viscosity. That said, I have checked my fuel trims and air-fuel ratios, and things seem to be normal. And I don't have any engine codes, so it's something to continue monitoring. With more samples and more analysis, it's something I can figure out if it's actually the beginning of a real problem or nothing to be concerned with. And that's kind of the whole point of this oil analysis, right? You're looking at the health of your engine, the health of your engine oil, and you're monitoring things so that you can catch things before they become more serious problems. You can look into things and make sure, hey, my engine health is good, everything's going as planned, or if things pop up, address them as needed. So this was my first time doing an oil analysis, and I found it quite fascinating. So I hope you enjoyed learning about this as well. If you have any questions or comments, feel free.
برق در واقع میشه گفت نظر میخوام توی موتور و خودرو بوده. ما میتونیم این رو توی کانکروشن ازش استفاده کنیم.
Rolling bearings are a classic example of condition monitoring based on structure-borne sound. With increasing
Machine learning meets acoustic emission sensing technology for condition monitoring. ببینید
increasing wear of the bearings, the acoustic fingerprint also changes. At the latest, towards the end of the bearing's life,
roller bearing رو ball bearing رو داره با هم تست میگیره. یکیش اوکیه، یکیش not اوکیه. ببینید.
It becomes noticeable due to a high noise level. In the simplest case, the RMS value can therefore be used as a damage indicator. However, damage becomes noticeable earlier. The first defects appear, grow, and can lead, for example, to small material fractures, so-called pittings. When rolling over such defects, subtle structure-borne acoustic pulses are generated, which propagate as a shock wave via the rolling bearing and can be detected and analyzed with acoustic emission measuring systems. The setup shown here consists of two bearings that are powered separately. The rotational speed can be adjusted via a potentiometer. A VS150M sensor is mounted between the bearings on the mounting plate. The sensor signals are acquired by the condition wave, a two-channel acoustic emission device, pre-processed and transmitted to the PC via the network. The left bearing is undamaged, the right bearing is severely damaged. The differences between the bearings can be clearly identified in the spectrogram, both acoustically and visually. The impulses that lead to a harsh noise impression have a broadband effect and clearly stand out in the frequency range from the operating noise of an undamaged bearing.
چقدر شبیه سازیشون و تستشون ریل تایمه و سنسیویتیش چقدر بالاست. به محض اینکه دکمه خاموشی میزنه شما اینجا تو نمودار و گرافاش میبینید که مقدار به اصطلاح اون حالا FFTش و حالا میشه گفت دامنه نوساناتش به صفر نیست. ببینید
Based on the differences in the frequency range, a model can be trained to distinguish between the intact and defective bearing. For this purpose, training data of approximately 2 minutes is recorded from each bearing. Since a defective bearing can already be detected via the sound level, the rotational speeds of both bearings are adjusted to such an extent that a separation of the bearing conditions is only possible via the spectral properties. The training data are stored in 2 different measurement datasets, OK and not OK.
چند لحظه صبر کنیم که حالا شما به جای این بال بیرینگ میایید به جاش چی قرار میدید؟ کانکروشر قرار میدید و همین تست رو انجام میدید. حالا واسطه سنسورهایی که موجود هست.
The classification model is trained with visual class. For this purpose, a new project is created and the various measurement datasets of the classes OK and not OK are specified as training data. Spectral characteristics or features are now extracted from this data. At this point, only a rough outline of the workflow is presented. Each feature on its own still shows a strong overlap of the classes OK, not OK. However, a higher selectivity can be achieved through a systematic combination and transformation of features. The next step is the feature selection. At this stage, the features are evaluated and selected according to their separability. The top 50 features are selected as a first attempt. The final step is the actual training of the model based on the extracted and selected features. The classification accuracy with previously unseen test data lies at 95.8%. As anticipated, the classes, here green OK and red not OK, can be easily separated due to the selected and transformed features. With the help of an automatic parameter search, the settings of the feature extraction as well as the selection can be optimized. Here, you can see how the number of features is automatically optimized. The aim is to maximize classification accuracy in the test data and avoid overfitting the model. After optimization, a classification accuracy of 96.9% is achieved on the test data. The model can then be exported with the optimized parameters. With the exported model, new unknown data from rolling bearing measurements can be classified offline as well as in real time. To do this, we start a new measurement. For the current acquisition, the feature extractor is also started, which receives a link to the current measurement file as well as the exported model. As soon as a new dataset is recorded, the features for it are extracted, selected, transformed, and the classification result calculated. The measurement data is visualized with Visual AE. To display the classification results, we create a new diagram and select the result from the feature extractor as the data source.
Monzo.com makes GANs great again. Yeah, you know what? I'm not going to say again because they never were, and
Despite the standstill of the bearings, class 1 is displayed as OK. Why is that? We have created a classification model that can only distinguish between two states, OK and not OK. The stationary state is unknown. Even if the state is far from the known state, the classifier must decide on a class. A possible solution is to train the stationary bearings as another class, hence the noise of the measurement chain and possible ambient noise. However, since the state differs so much from the operational bearings, a simple RMS threshold, for example, may be sufficient. For this purpose, we implement a short upstream logic that classifies all datasets with RMS values smaller than 20 microvolts as standstill or class 0. For larger RMS values, the result is given by the classifier. Now, the stationary state is correctly displayed as class 0.
می‌دونید چه صدای گوش خراشی داره؟ این در واقع همون ماتروکیه است. این یعنی که سیستم مشکل داره. حالا از طریق چی متوجه میشه؟ از طریق صوت سنجی، یعنی سنسور صوت سنجی که اونجا وجود داره، یا از طریق ارتعاش سنجی هم میشه فهمید، چون صوت و ارتعاش با هم ادغام شدن. خب این تا اینجا